the session before lunch. I'll keep it short so you can eat long. My name is Drazen Jankovic. I'm a front-end developer at Society, senior technical consultant, as they call. 39 years old. I specialize in accessibility. I do cosplay, which, not in this picture for once. But it is in the Frontmania magazine. You'll see me with an Iron Man helmet. I'm a gamer, and recently I started playing disc golf, and it's become such a problem where it's like, are these plates or are these discs that I have in my house? I don't know. So, you know, a little bit. But today we're going to talk about voice user interfaces. What are they? How do they work? And we're going to go into a little bit of a demo showing some code. So, the agenda for today: what are voice user interfaces? Why do they matter? How to get started with it? What is the web speech API that we're going to be using? How do you integrate all of this? Demo, and then some of the challenges and best practices with it. And what's the future of it? Take a seat. So, a little bit of the history. When was the first voice user input ever made? What do you think? Like actual digital one, so not like somebody yelling at somebody miles away or something. Give a take? Sorry?
Probably the 70s.
70s? A little bit earlier. It was called Audrey in 1952. The only thing Audrey could do was automatic digit recognition. So you would speak into a microphone 2, and then push a button for plus, and then you say 2, and it would show 4. So there was still a lot of manual work, but it was doing things as recognizing it. So it made a lot of the work easier for people working in, at NASA, for instance, where they had to go through a lot of numbers, just constantly repeating them. So Audrey was very good at that. A couple of weeks later, in 1984, as technology evolves, the next iteration came, and that was generation 2. It was called interactive voice response, and we still use that today. It's whenever you call help desk or something, you get that message of, please say, what is your postcode, so we can know who we're speaking with, and then you would have to say it. So that's that system, invented by Speechwork and Nuance. It started up, as I said, in 1984, still in use today, but the next generation is already taking over. In the early 2010s, human-machine interfaces became a thing, and that's basically what we're using now a lot. Who here has a Siri, Alexa, or Google Voice Assistant? Probably all of you if you have a phone. So, so those are the new major three. What sets these apart is that AI is now coupled to your voice, but also the voice coming from the machine is coupled also to the AI, so you can actually have a conversation. Not the best, but you can. And it really depends on what AI model is running behind it, whether it will be a good conversation or whether it will tell you to buy stocks or something. It's very weird what kind of things you can get, especially when talking to Alexa for some reason. So yeah, what are user interfaces then when it comes to voice? Basically, it's any interaction with a device, computer, or app that uses your voice. At this point, basically, your voice now becomes an input device for these machines. The main advantage you get is you can talk, you can move, you can look at something else while the machine is doing what you're saying. So you can be completely disconnected from the technology itself. I wanted to do the entire presentation with this by just using certain keywords, and then my slides would go. But when I tested it last night, even a little bit of noise makes my slides go by super fast. And knowing that most of these here are my colleagues, I know they would notice and they would immediately start yelling things. So, so why do voice user interfaces matter? Very simple. They enhance your accessibility. They make web applications more user-friendly because you now allow things to do that normally you would need a keyboard for. Very useful for people with motor and visual impairments. As you can see, I constantly have to go back to push a button. I wouldn't need to do that if I could just tell it to go to the next slide. And since the entire web is moving more towards more inclusivity, this is what you then get. Like, this is at least one of the examples for why they matter. Google recently released a new updated version of Voice Assist. So you can tell your phone to take a picture, ask it to send an email, or send somebody a message. And with the next iteration of Android that's coming out, you'll even be able to, let's say a marketing company calls you, the phone will answer for you, ask them, why do you want to speak with this person? And then it will send you a message saying, hey, do you want to speak about this and this with this person? And you can say, no, because who wants to pick up a marketing phone call? So yeah, it's basically an inbuilt voice spam filter. Again, hands-free and eyes-free interaction. Users can perform multiple tasks at the same time because you're no longer busy looking at something to do something. Just for me to switch my slide, I have to look at my screen to see where I am. I have to use my hands to do it instead of doing one or the other or none of the all above. GM Motors has their new interface, which is fully digital. Imagine having to look at that screen, push buttons. Meanwhile, the road is just flashing by. So with this, with the new Fords, Chevrolets, and anything GM Motor related, you'll just be able to use voice to tell your car, for instance, speed up or slow down or set a speed to a certain limit. So we get to the point where, since most of us here are front-end developers, how to get started with this, and how do we actually get started with this on the web? Because the other ones use AI. The web, not so much. We're very limited with what we can do with JavaScript compared to if you could connect, for instance, Python to this with a TensorFlow model and everything. So first, we need to understand what are the classifiers. If I say the word right, what does it need to do? How do my acoustics look like? Then once you know that, you can make an acoustic model to see how all of these are spread. Once you know that, you need to do some very heavy math to make your own model for the beginning and the end of the word to get a temporal structure. Once you know that, you can do the transcript, pronunciation, phonetics. If somebody has an accent, like I do, process all of that as well. So you need deep neural networks to do all of these things, and it's too much. It's just way too much for what we want to do on the web. For us, when we look at web user interfaces, we want simple actions to do simple things. A simple form should do what it's meant to be. If I have to input my name, it's easier for any developer here to just go, no, just validate the input, that's it. But if I have to do voice and I have to go through all of those models, you know, it's way too much work for very little payout. So Web Speech API came in. And what it allows to do is basically a lot of the processing has already been done. You don't have to think of the models. You don't have to think of the acoustics. That's already done for you. All you have to do is match your action with what's being said. And that's way easier to do. I swear this is annoying me. It's just squeaking under me like I'm walking on gravel. It's so yeah, with Web Speech API, I can give a command saying, click on this button. And my website could also just answer me back, no, I don't have that button in view, or, okay, clicked it, this is the output. And it can also use talk back to me. Because the API consists of two things: recognition. This is the part that recognizes words. This is what we'll be going into today. And synthesis. And this is where it talks back to you. The talking back, you don't have to do that always. Sometimes it's nice. Sometimes it's just something visual is fine as well. No pee-pee. How do you integrate it? Well, it's fairly simple. You only need to pull in 3 things into your project. They need to be speech recognition. This is the main model, the main controller that's going to do everything. Speech grammar list. This is a list of words that you're going to be checking for. There's a pre-made list, but you can also add your own words to it. And then the speech recognition event. This is the event that fires when you start talking, when you stop talking, anything in between gets covered by that. So like I said, once those are in, there's just a few more things you have to do. Provide your own grammar list. You can use the Java grammar format for that. And I know it says JS, but it's actually Java scheme grammar format, so I know. Don't kill me on that. Here we have a simple one. It's just a bunch of colors that I added to a list. The constructor, you then create a new speech recognition, follow with the grammar list, add all of the words to it. Very important. What language am I speaking in? Am I using a dialect, yes or no? So you can use those all in here. If you don't set this one up, whatever the default is of your machine or the default of your browser will be used. And that could cause a lot of funny things. So try that, I would say. Some of the other things that you see here are continuous and max alternatives. Continuous basically means that should it stop after every word I say? Once it knows a command, should it stop, yes or no? And alternatives is, let's say I say the word ball. What did I just say? And then it will go over a list because it couldn't match a single word. It will go over various alternatives and how to use them and try to match one of those to it. Or actually, you will go through it. And then the final step, let's say we have an element called output. We're just going to provide what you just said. We're going to put it in the output, and we're going to change the colors of the body. So how does that look? Here we have a little example. All of the examples that I'm using today, they're all in CodePen, so there's a link at the end for all of them. This is one of the base ones that every tutorial will show. So what we'll do here is if I click anywhere on the body, did it already start? Because it says result receive internet. Let's refresh. Make sure that I have a clean one. There we go. So it says diagnostic message. So if I now tap somewhere, red. Is it not listening? Ooh, it better be listening to me. Live coding, people. This is why I don't do it normally. Oh, yeah, it's actually reading up words now. All right. Red. So there you go. Working example, yes. Basically what we did is what I said, if we take a look at the JavaScript, it's the same as a moment ago. We just go over the grammar list that we provided with all of the colors. And then once a color has been found in what I said, to read out the transcript, which you can find here. Once that has been read out, apply whatever is there. And you can then set up things like recognition error. What if I didn't recognize anything? What if somebody just kept talking and there's now a full sentence? You can pick up all of those from those events as well. So the breakdown, once more. Clicking on the document starts the recognition. You can also start this at the start of your page, but we'll talk about some of the issues you can get there later. On result, whenever a result comes in, grab the events, grab the result, 0, 0, transcript. The 0, 0s, basically the results is always an array of speech event results, and each of those results can also be another speech event, so you can have multiple answers. So the first one goes over, sorry, can we do this? Whee! So the first 0 goes over which event result do you want, and the second 0 goes over which alternative do you want from that result. It's easier written than what it actually does. This is the documentation by MDM, and it's literally this. So the first, as just what I said, each of these results consists of multiple speech event results, which can be another result, and so on. So you could actually have a full conversation and only pick out a few keywords that you want to do and fire the actions on those. So the event can trigger multiple times. That's why we see those double zeros. Using the grammar list, we can even add our own words. So let's say there's a color that I like, but it doesn't have a name. I could give it a name and then connect it to a RGB value. But as we saw in the demo, it only fires once. And this has to do with that continuous false that we set at the beginning. What you want to do is that your app keeps listening to any changes made. And we can see that here. I know it looks exactly like the other one, but in here, what I've done is I've set the continuous to true and iterate over every event result that comes in, adding a new, grab the next item in the speech list. Let's see, are you listening? Yes, you are. Cool. Ooh. Oh, no, it's already started. Okay, okay. Ooh, scared me there. Blue. Gold. So now it will just keep going with each word, and you'll see what the confidence level is of what it's doing. And it will also just keep listening to me. No matter what I say, it will just put it down and hope it's a color. So these are the things that you can pick out and do things. It's very confident at what I'm saying. It just doesn't know what to do with it. So these are the things you have to think about when doing this. See? I love this. My neighbors got crazy because I just kept yelling colors in the middle of the night. So some of the challenges that we see, it's not as strong as their AI-powered partner because it's trying to somewhat guess what you're saying and trying to grab alternatives to it. And the speech API behind it is fairly powerful, but you did see that most of the things that I said were 0.89, 0.95, while you're looking to get as close to 1 as possible. And the AI-powered ones, for instance, if you're using the Dream AI by Google, when you say certain things, it will iterate multiple times over them to get that 1, to fully understand what you actually said. Still doesn't do it if you speak with an accent. So you have no idea how often my lights turned on when I just wanted it to shut down my alarm. So it can only match a few words at a time due to the grammar list. You saw the entire sentence. For me to then match it, I would have to make an if statement going like, if, then what did I say? Something a lot about selecting colors based on blah, blah, blah. So you can only, it's very strict in what you're doing because you have to hard match it yourself. It's not a lot of the things that AI can do, where it's predicting what you're trying to say. Browser support, yay, everywhere, except Firefox and Opera. And I don't know why, and they say they have plans to do it, but they have not provided any info on when or how. So it's weird to see that every other browser supports this, except for Firefox and Opera. Like designing for mobile, voice has its own rules and principles, because if you just make an interface and you start talking as normal, you won't get the same feeling, same results, same things as when you're making a website. So the 6 principles, mobile first, so voice first. Do your input fields have correct names that are easy to access? Do your colors have correct names? Are you using the same naming for colors, for instance, as other countries are doing, as other people are saying? If I say gold, Elena, did that look gold to you? No, see, because Elena and me have different standards of gold. Also, I'm colorblind, so for me, I don't know what that color was. It looked way more orange than gold, but yeah. So when designing for voice, you have to think of it as designing for mobile. You have to have a specific experience planned out from the start. You cannot just add this afterwards. Maybe for a few simple things, but not for everything. Natural conversation. Saying a single color, easy. Saying a single input field, easy. Having a bigger sentence where somebody's trying to explain something, a bit more difficult. But what you could do is, for instance, when you have a help chatbot, for instance, that you could just use your voice to fill in that input. So the chatbot is already answering in natural language because it's coming from an AI-powered source. So why not just use the input to write down for you? Personalization, like I said, different people have different names for things, accents, dialects, things like that. So how do you pick those up? Tone of voice, is somebody being angry or not? If you're using synthesis to speak back to somebody, how are you going to speak back? Is every message the same level of intensity? For instance, if I have 2 alerts and one of them is like, wow, your computer is on fire, should it then say like, hey, your computer is on fire? Or should it be like, put out the fire, now, 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 you know, like very aggressive. So if you're going to use aggressive colors, also add an aggressive tone of voice to your speech synthesis. Context of use, again, what are you using it for? Like I said, 2 different alerts can be read very differently depending on how you're using it. And sense of trust, and this is one of the biggest principles, and what I said with earlier, why the continuous listening really matters. Because let's say I am disabled, I'm blind, I'm using my app or my web to log in. And I say, log me in, my username is Drazen, my password is 82173. Okay, now everybody heard the password. And in worst cases, sometimes there's a synthesis back where it's saying, hey, can you confirm this code to us? Is this your password? 82173. Not the best. And we often see that when people are using TalkBack or Siri to do accessibility. When they have a password field, as soon as you start typing, it starts reading out loud what you're typing. And on a password field, not the best. So the context of use is also where is somebody situated? Do they have a headphone on, yes or no? Are we now going to read out the entire password? Or should we first give a warning like, hey, this message is about to be read out loud. Make sure you're somewhere private or something. So yeah, there's a sense of trust there. Avoid offensive content. Saying certain words in one language could mean something completely different in another. For instance, T-Mobile recently changed their name from T-Mobile to Odido. And they didn't do that in Spain. And the reason is, in Spain, it means to be hated. So, you know, not the best name for your company, especially if you're a provider. So things like that, like make sure that the content you're saying back doesn't have any extra meaning that could be suddenly read out loud. And try to avoid purely promotional content. This is basically, it might sound like you're giving them information, but it also sounds very much like you're reading out an advertisement very loudly on their device. So is this something you want to do? Yeah. So what is the future of voice? Basically, the models are getting stronger. Speech API has been getting more and more updates on the back end for what it's doing and how it's doing things inside the browsers. So the experiences can get stronger and stronger. I also now notice that I did this in 30 minutes. Wow. So, you know, you can make these experiences small as you want. It could be just very simple inputs. It could be something very large. It could also just mean that you're making something easier for yourself to do. One of the things I have running is usually that often when I'm developing things with my 3D printer or working on some designs for it, I tend to think out loud. And then I can just say to my PC, hey, write down the following note. And it should just follow my voice, whatever I'm saying. So I could be busy with something else and do those things. And with web, very easy to do. How often has somebody, when you see the promotional videos of inclusivity, you see people holding a baby or doing their grocery shopping. Now try to input your tax data. Things like that. So make it easier for your user by using these things. And I'll show one more. So one more example. It's basically how to do like input fields. Changing colors is one thing because it's just reading out something there. But you could also do things like this. Have to wait for it to process the reading. Wings. Please do it. Oh, I hate you so much. No, thanks. Let's refresh this page. Make sure it's reading again. Again, experimental techniques. Who would have guessed they don't work sometimes? Wings. I said wings. Oh, thanks for writing down, I said wings. Cool. Wings. Fire. There we go. Again, don't speak with accents if you're trying to do voice. Wings. There we go, yes. Basically, again, it's like you see the confidence just jumping up and down and what it heard and everything. It's all about how do you then process these things. Are you going to make your grammar list bigger, smaller, and what are you going to do with it to actually make it more confident in what it's heard? I believe that puts me on the questions. Yeah. Hello, Elena. What do you want? Another review?
If you say wings again, will it deselect?
Yes. Wings. Fire. Because it's basically a little toggle. Or there.
How do you deal with multi-language input? So
Multi?
you define the language
Yeah.
in which you want to listen or reply, but also when since English is a really big language and used very often, but also, for example, which Dutch elements in it. When I want to navigate to a certain street, the settings are in English, but the Dutch street is not recognizable because it needs to be some English pronunciation.
Yeah, it's trying to read out the English.
Is there a way to deal with it?
Currently, you can only run one recognition or one synthesis at the same time. So when setting it up, you set up what language you're doing, and that's it. So it's on that one. So what you could do is you could make a drop-down, for instance, like read this with this, or you could just chain them together. So for most of the things that I'm saying, say those in English, but when it's answering back, because you know it's going to be a Dutch address, you could quickly switch language in between. So, but that's really up to you. Yeah, yes. So the language thing is just a variable indeed. So you could just keep switching it back and forth. Over there.
Yeah, I was wondering, did you look into the performance of this, right weight?
It doesn't weigh anything because it's already built into your browser, the speech API. But when looking at performance, like you can see already here how quickly it does. You could do something called interim mode, and what it then does is every word you say, it will start writing it down, and then changing the confidence as you are speaking. As you are, see? This one is currently set up to always wait until I make a pause and then continue. So the performance part is really up to you how far you want to go with it. I think... I think Google has one demo with it. Yeah. So as I'm speaking right now, it will immediately start adding, and you can see the words changing as it's trying to get better with things. So it's fairly quick and everything with it.
And I guess also, performance side also, memory, is there a lot of memory being used for this?
It's very low in memory use, at least from what the documentation says and what I've experienced with it. It never went into a point where it was almost crashing my browser, and I use this in Chrome, so you know how much that memory uses. So,
Could you get multiple tabs?
multiple at the same time?
Well, say you had a tab that was not active,
Mm-hmm.
but still listen to your...
No, only the active one, and that's a security feature. That's one of those trust us, because I could set this up in the background to listen, like make a small malicious piece of code, push it along with an ad, for instance, and then constantly listen to what people are saying. So that's why most browsers nowadays disable all audio from other tabs, or they show that they're listening if something has overwritten that setting. So, yeah. Any other questions? Oh, over there.
Yeah, I was wondering, because this doesn't completely ship at the browser, right? Because your data will leave your browser and go to some Google server, right?
No, it's inside the browser. It doesn't ship to them. Yeah.
Process
Yes, this what I understood, the speech API is fully on your own machine. So performance-wise, if you have a slow machine, yes, it could impact because your own machine is trying to recognize it. Because the models that they're using, it's not using the full model like an AI to get all of the words and everything. It's just using that grammar list that you have and then comparing the transcript with what's written in there. So it shouldn't do it. If it does, it's a bad implementation of the speech API. Over there.
Yeah, so I think that was impressive with the accessibility features and screen readers like browser. Is there a compatibility possible with this?
Yeah, so it's fully compatible. If you have a device that uses TalkBack, for instance, if you have a device running that, it will recognize that speech API is on and they will communicate with each other. So you could use both at the same time. If you want to go extra above what TalkBack is already doing, then you would have to implement it. Yes.
By saying that there will be an icon on each tab that is recording, are you saying that it is actually possible maybe to put it in a service worker and to keep it active in the background?
I'm not sure if you would be able to put it in a service worker, but it's just that sometimes at least I know for Chrome, that when something is using my microphone or my speakers and that tab isn't active, it actually shows them as doing that. But what I noticed with Speech API is that it actually shuts them down when the tab is not active. So probably because the other tab is at the moment is using my microphone, so only one tab is allowed to do that. So
Yeah, but the service worker is usually there to
probably you could do it, but
the
yeah.
idle thing.
Probably you could, but like I said, I stick to the 6 principles where don't be a dick. Let's call that principle 7. So yeah, back there, and then we'll go.
So do you know if speech API is implemented in OS level or it is implemented in browser level?
I think it's browser level, but communicating with the OS level because most OSs have something of a voice input recognition, so it's just communicating back and forth there.
The browser is not implementing anything, it's just the phrase talking to the OS, right?
Yes, no. Again, multiple documentations are saying different things yet, so I'm guessing that's also why Firefox and Opera have not implemented it yet, because there is that misunderstanding there. So. But considering how it's doing certain things with how I'm pronouncing words, I'm guessing it's communicating back to Windows because the Windows speech recognition has so many issues with my voice. So, yeah. I'll do this one first, then I'll come back. Yeah.
Yeah, I was wondering, has anyone tried making like a fully voice-based interface?
Yes.
So, like, navigating through your app just using voice?
So there's multiple projects. Not sure with web speech itself. Probably there are as well, but there are a lot of video games, for instance, that use speech recognition that works very well. One of the first one was Hello Pikachu from the Nintendo 64. You could buy like a little upgrade, and for the DS, where you could play Mario games, and then at one point it would say, try to imitate this character, and you would have to imitate him. But if you yelled, it would be always better than actually doing your best. So how good those implementations were back then, don't know. But the current ones, there's a Tom Clancy game, for instance, where you can order your soldiers to move in certain ways just by giving them voice commands. There's a lot of apps that are dictation fully that use these things, so yeah.
And what about like a regular website? Are there any like common patterns that people use to, navigate through a regular website?
So most of them use the patterns that are built in for accessibility features, so things like landmarking with sections and articles, for instance, that you can already use and connect, which connects to what you asked about accessibility through other means. So they can reuse those parts. But things like giving everything a good idea or a good class name or just a name in general when it comes to input fields, that will already help you a lot, because then if somebody is using assistive software, those will be read out as, hey, this field is here. And then you can just say, okay, take me to field name, and it will do that.
Would it tell you then that it's possible to speak, or how is it communicated to the user?
Currently, if you want to do that, unless you're using assistive technology, it will not show anything. You'd have to put down your own message, like, hey, you can communicate with our site. But if you're using assistive technology, it will actually read out that something is available for speech and which words are triggering. So, yeah. But that's also a bit dependent on the implementation of the assistive tech. So, yeah. But most do that. So,
Yeah, I had a quick search on the MDM docs for this, and it has a big note that says on some browsers like Chrome, it uses a speech recognition server,
Oh.
where it sends it to, and that it doesn't work offline. Can we turn off your Wi-Fi and see if it works? Then you know
Sure.
data gets sent to Google.
That would be nice. To actually, I mean, I can just look in the network functionality as well.
Yeah, but it might hide it.
Where's the Wi-Fi? Am I not connected to Wi-Fi? No. Airplane mode. Let's go.
Don't reload your code then.
Yeah. This is a test. Oh, you're correct. It's actually sending it out. Yeah.
That's tricky with SIP data.
Yeah. Well, interesting. Like I said, the various websites for this show different things with what it's actually doing, and it's sometimes it's confusing to find out what you're actually doing. So yeah. Cool. Good to know that it's actually sending it out. Sorry. First, and then there, and then there.
Yeah, by any chance, as you know, Chrome has a feature of live captions for videos and stuff, which doesn't have subtitles. By any chance, does it use the same engine?
For videos, I don't think so. I think they're doing that on their end, where they analyze in the back end what the video has done, and then provide a transcript. But I'm not sure.
So it is live captions. So
Oh, it's a live caption?
Chrome, so it's gonna recognize the voice that is playing from Chrome and
Yeah.
subtitles.
I'm not sure if they're using this.
Right now you can see it. But you think you need to try to make sure that it doesn't? Can you play some video?
Sure. Baby shark. See? Ask weird things, get weird things. Let's make sure that this one is recognizing now. Cool. No, go away. Is there no sound coming? Oh, is it because I'm connected to...
On the top right, there is an icon as you see. Yeah, no. Yeah, no, the right one.
Oh, this one.
Yeah, can you enable live captions?
Sure.
Yeah, it's downloading something.
Yeah, so it's probably coming from a transcript in the back end there. Yeah. Would be amazing. You're trying to dictate something nice and it just says, get groceries, baby shark, and 2 eggs. It's like, okay. So yeah. Yeah.
Can you set up something like a wake word with this? Because if you work with Alexa, there you can use the wake word like Alexa, and
Yeah.
then it starts listening.
Yeah, you could. So it's not really a wake word because it's continuously listening, but you could make it ignore everything else until a certain word comes up. So, but that's just part of your if clause.
But it will still listen during
It would listen constantly. Because once you pause it, it's not going to use our microphone, so it will never hear the wake word again. So,
Yeah, because Alexa, the API claims that they only start listening when you say Alexa. So that's
they listen to sound spikes and then try to recognize if that spike was Alexa, and if so, then do it. Otherwise, ignore everything else. At least that's what they say, so who knows. My ads also turned into things that I don't buy, so yeah. Let's go over here and then, because I saw the sign, 5 minutes.
Do you think this will get bigger in the future? As in, how do you think it will develop for web? And how do you think it will develop in the future for more augmented reality glasses, for example, that don't have a physical interface?
A lot of augmented reality already uses things like this. I believe both Meta and Apple showcased it in their demos as well. And I do actually see this going further because as you saw, it's already trying to be implemented in cars to give them functionality, and I just see this going further and further. And since more things are going into web interfacing, yeah, can't wait to say to my fridge, give me a Coke, and I get a Coke. It already has Java, so why not? So, yeah.
Do you know if the browser devs are still developing the web speech API, or has it been sort of stale since initial release?
No, they have been developing, because when I first thought of this last year to do as a thing, it was really, really bad. So I know they have been developing, and looking at the timelines that they've put towards W3C, it looks like they're actually continuing on it with a roadmap, which is, you know, you never know because it's a roadmap on tech, so who knows. But yeah, they are. And there was one more there.
Sorry, so in Firefox, we still have the ability of using microphone, right?
Mm-hmm.
So is there any third-party AI somewhere so we can use the API to have the capability in Firefox as well as have more accuracy and receive better results?
Probably, but then it's going to probably be some paid AI. I'm not sure if Google is offering their services that you can connect to that API, but I'm not sure. That goes beyond the scope of web speech API, so I didn't look fully into that one yet.
AWS has a service for that?
Oh.
Accurate speech text, something like
Yeah.
that?
I know that with Google you could do it and then send it to their tensor that they have set up, because a lot of the do-it-yourself home kits, when it comes to like make your own simple AI or voice assistant, they all use that. So you could probably link to that one as well through a web page. How effective it would be, how stable it would be, the performance, no idea, because the Python code is already, in their own example, having a lot of issues. So yeah. So if there are any more questions, I'll be at the Society booth in the center of the hall, basically, and I'll be there to answer, because the 5-minute mark was waived, and I'm guessing everybody's also getting hungry. I am, so. So yeah, I'll see you there, and thanks for joining, and hope you learned something.